remember, which I can't, and therefore we reminded me, which I say thank you. Okay, so let's see. So I'm going to encourage that we parallel play. I'm going to encourage that we may not get through everything today. We may not even get close through everything today, but we could get started.
Okay.
Okay. So, and you guys sent me the data, right?
Yes.
Okay, so I clearly didn't grab it off of.
I believe Dr. Demers attached it.
I think you guys shared a.
Maybe she didn't share it. Oh, it's right there.
Okay.
That one.
So we'll grab it from here. We'll save it. I think I made some modifications in there already. So before we save it over, I just want to remind us. So we have paper, site, we have acronym, we have 3 different conditions, GCL, campus, and GCE, Susan, wet, dry. GB number, what's that?
Gambusia number.
Oh, so that's the individual ID for the animal.
Yes.
Okay. Sex, these should all be female. Anal fin 3, 4, 5, 6, 7. And this is the one that we're most interested in. And this is a rank, if I remember correctly.
Yeah, so it's just an intensity scale. So based on the range given, if it falls within that range, then if it's like less than a certain number, then it's a 1. If it's between those 2 numbers, then it's a 2. And if it's over a number, then it's 3. I can't exactly remember the numbers. Oh, but yeah, right there. So like if they're between 1 and 1.2, that's considered mild masculinization.
Oh, right. Okay, so what you guys have is, in terms of analyzing data, is exactly what you should have. You have a large, full set of data that you describe completely out the way that you want. What you then do is either here in Excel or you do it in R, you pull out the things that you need. And based on your hypotheses, remember correctly, we're going to need this, right? We're going to need this, potentially this. And these are not formulas, is that right? So the formula is already done. How do you guys make these?
So those are not those anal fin 3 to 7. They're not formulas. They're just numbers. So when we measure, it's like a measurement shows up, and we have to type that in manually.
How do you make this? The 4 to 6?
Oh, the ratio. So that is an average from 3 anal fin 4. Over 6.
So it's the ratio of anal fin 4 to anal fin 6.
Yeah.
Yeah.
Are you confident about these? Oh, no. Okay. So that's 0.336, 0.335, which is why you basically get 1. 339, 337, 1.01. Am I saying that correctly?
That first number, Marlene, that first number shouldn't be just a 1, right? I don't, let me check. That doesn't seem right.
Well, they're basically the same number. No more than a thousandth of a decimal point, right?
Then maybe, yeah, okay.
So any rounding is going to round directly to 1. As we go down to the bottom, we see greater departure like 447 to 344, 1.3, and so on, all the way through. Is that right?
Yep.
Okay, so abbreviation for paper. What is G3, G5C, G3, G5C?
So the C stands for control, and then we're not allowed to use the names in our paper because they're all anonymous resources. So for the sake of the paper, like if we're referencing Crown Colony, then that's golf course 2, I believe.
Okay, so these are sites. Am I understanding that correctly? But they're abbreviations for sites. But like if we make a figure, you can't say Spring Run
No,
Condo.
yeah.
You can say G3.
Exactly.
Do I have that correctly?
Yep.
And C is the control. But control you can say, is that right?
Yeah.
Why don't we do that? So if I remember correctly, your stuff was pretty clean. And what you always do here, and I think you basically already did this because I remember going through it, is we're using filter to just make sure that you're saying every single thing the same. Because if you put C and control, C in one cell, control in another cell, the computer's going to assume they're different things and treat them as different, even though you mean for them to be the same. I might as well just call that control. Okay, we're not going to show these, but that's fine. We're not going to show these, that's fine. Now you have some questions where you want to compare GLC and GCE, is that correct?
Yes.
Do you want campus as part of that? So I'm asking you, do you want to compare basically 2 groups or do you want to compare 3 groups?
Marlene, it's lake versus effluent, but then also both of them versus control, right? Or campus.
Yeah.
What does lake and effluent stand for?
So
Oh, go ahead.
so lake is the areas where the lake was actually natural water, and then the effluent is the one that is reused water.
Okay, okay. So these are conditions of lake where GCL is natural water and GCE is effluent. Is that right?
Yeah.
Okay. And water body means that we have campus as well, natural lakes and effluent. Is GCL and GCE important to you?
Yeah.
Which is clear? Natural water and effluent or GCL and GCE?
Marlene, which one do you think we should use? Should
We
we
can
use
decide a bit. I'll give you a hint. The right answer is the words.
Oh,
Do you know what the acronym means? Okay,
Yeah.
you know what the acronym means. Do I know what the acronym means? No, and
Okay.
you're trying to communicate to me. So whenever you can, you try to use words.
Okay.
Season looks good. Wet and dry, this is perfect. GB number is just an identity, that's perfect. We have no males that snuck in there, that's perfect. Anal fin 1, 2, and 3, these are all gonna be proper numbers. And then we have intensity. All right, so am I missing anything? Oh, I want to do this real quickly. Let's do lake and let's do. So this column is just going to be GCL and GCE. This column, if you want to, is now GCL, GCE, and campus. So if you decide you want to analyze with campus, that's available to us. If you decide you just want to analyze natural lakes and effluents, that's still present there. Make sense?
Yep.
Okay. All right, so we have your file. I like to put the names, I like to put the dates just so that so let's create this. Oh, there it is. Okay, and that's code. Okay. R is a coding-based software. Like any other language. A few things to know with it. One, hashtags are notes to yourself. And these are good so that you remember what you are doing. Lines without hashtags are code that the computer is going to operate and do. This area is where you can develop your code. This area is where you run your code. This area is where you'll find out sort of your environment, what data sets you are using, what you're not using. And this area down here is a variety of things. It's everything from our data and our outputs to our plots to what are called packages. They're like add-ins that you can put into a program so that you can have more functionality to help and all those things. Do not expect to have any of this memorized. What you want to do at this point is think mostly through the questions you want to address, mostly guiding my hand in terms of what you want included and thought through, and then also asking every bloody question that pops into your head in terms of what you guys might want to be doing and why. Make sense?
Yeah.
It's not going to be one shot. I think by today, what we will be able to do is get the data in and maybe address a single question so that you can just at least see the overall idea and the overall framework. Make sense?
Yep.
Yeah.
So the fact that this is a hashtag, it tells us we're going to load packages. Packages are add-ins to the computer. And we're going to load in the, we actually may load in that one too. So I'm going to leave these little notes, which tell you what each one of these do. We'll get rid of that one. Get rid of that one. Those. Okay. When we run it, what happens is it sends the information down into the console and it performs a task. Some things take a little bit of time, and that took a few seconds. I like to take code that I've already built so I can sort of reuse it every time. This is going to create a matrix in R. It's going to read a particular type of file. You know you have the Excel file. This is the same idea. It's called a CSV. It's an Excel file that defines cells by commas. So it's a simplified version of Excel. It's something that's very easy for computers to read. So that's why we did the save as, and that's why we changed things. We're going to get your data, which is in our folder data, and we have your data right here. We run that, and we have a bunch of information that goes up here, and we can see where we have your data in Excel. We have a bunch of things that we need, and we have a bunch of things that we don't need, right? Like we don't need these columns over here, even though they came with us.
Right.
We do need these columns over here. Does that make sense so far? So we got that in. The next thing we're going to do is we're going to sample the variables that we want, that we're going to use to analyze. We have our data, our Excel file, that stays the same. We don't care about that. So we're going to go through these and we're going to create another matrix that's based on the matrix that we have, that we see over here. We're going to decide which variables do we want. Do we want site? Do we think we're going to use that to make a figure or do an analysis? Are you going to compare sites?
Yes, we are.
Okay, so we're going to select that. We're using this command called select, and we're going to choose that one. Are we going to use site name, spring run condo? And I said, no, we're not going to use that. Are we going to use acronyms like SRC, CMCDB? That helps you, but no, we're not going to use that. How about lake? Is lake going to be important to us in terms of analyzing, in terms of understanding? So let's grab that. Okay, what about water body? In terms of GCLE, campus, we may want that. So let's get that one too. R doesn't know what to do with spaces. So for that, we have to put these little, almost like asterisks above it.
Right.
What about season, wet and dry season? Do we want that?
Yes.
We want that. Okay. What about sex? Do we want sex? No, they're all female.
Those
We
are
don't
all,
need that.
yeah.
What about the anal fins? Each of the individual measurements. Do we need anal fin 3, anal fin 4, 5, 6, 7?
I don't think we need all 5. Right, Marlene? We just need 4 and 6.
And I
Yeah.
think what you need is the ratio. You don't even need the individual measurements, if I understand correctly. You just need to know that ratio. Is that correct?
Yes.
Yeah.
Okay, so let's get our 4-6 ratio. And then do you need intensity? 1,
Yeah.
2, 3. Okay. So now we have to tell the computer what type of information it is. If it's a number, then it treats it as a number and it's no big deal.
Hmm.
If it is a factor, like site, like water body, it doesn't know what to do with it. It treats it as what is called a character, which just means it's a series of letters and it doesn't make any sense to the computer yet. So we have to define all this.
Right.
So we need to define site as a factor. It's kind of a boring line, but you know, we still got to do it. We need to define lake as a factor. We need to define and I'm going to change this name a little bit so we don't have to worry about water body.
Okay.
Need season as a factor because that's wet or dry.
Yep.
What about 4-6 ratio? Is that a factor or is that a number?
Number.
The number.
That's a number, so we don't have to worry about that one. What about intensity? Is that a factor or is that a number?
Also a number.
Actually, that's a factor
Oh.
because 1 represents a group of measurements, 2 represents a group of measurements, 3 represents a group of measurements. So you're
Oh.
welcome. That was a trick question. And therefore, you know, I get to feel good about myself. Oh, I tricked you. Very exciting, right? It's always fun watching someone type. So now what we can do is we can subsample our data. And we get that. Notice we have a smaller data set now.
Mhm.
It only includes those things that we are interested in. And we are pretty good, pretty good, pretty good. Okay, so this also shows you how many times you saw something. You know, sites, we saw some of them a lot, some of them a little. Lake body. Let's see this again. Okay, that worked.
There we go. That makes
Water
more sense.
body worked, intensity worked, ratio worked, so we're set with everything. Okay. Do some of these have an order? And I think some of them do. Like you want control separate from G1, G2, G3, G4, G5. And that's a good order for that. You want effluents and lakes separate. That's a good order. Actually, these orders make sense. I'm fine with them. We don't have to do this. So let's put that. Let's close this. This. Okay, the nice thing about this and saving all these information is we can clean up everything, get rid of it, and then it takes 2 seconds to bring back stuff. If we got our code, all of our code works. All right. What this function is going to do is it's going to give us a standard way to present a figure. So it's universal. When you're doing a presentation like Research Day, it's nice to have something that has a particular aesthetic that's consistent all the way through. And that's all this code is going to do. It's going to give us that aesthetic. And this is the code that I use for presentations. So made a while back, it seems to work. I don't bother with it anymore, just copy and paste. This is the fun stuff. So what do you guys want to analyze first? What we're going to do is we're going to create a model. We're going to need to do an ANOVA or a t-test. That depends on what you guys want. And then we can look at responses relative to variables. And I'll walk you through each of those steps. But looking at our data, well, technically your data, what's the first question we want to analyze for today?
I'm going to start with the first question, which is the 4:6 anal fin ratio higher at all golf course effluents compared to all golf course lakes?
So you want to do this one,
Yes.
GCL versus GCE.
Yep.
Okay, so let's get our ratio, and we want lake. We want data, and let's see if this works. That worked. All we've said is that we have a model to this. Summary is going to give us the results of that. And this is what we get. Okay. Do you guys know how to read statistical tables?
Does DF mean degree of freedom?
Yeah, it means degree of freedom. Perfect. P prob is your p value.
Okay.
Based on this p value, do we have a difference or not?
Yes.
No.
No.
No, but let's go take a look at the figure. P values, when they are above 0.05, the populations are considered similar. P values, when they are below 0.05, the populations are considered different.
Okay.
Do you remember that?
Yeah, it's coming back now.
Yeah, no, totally fair. So, you know, so these. Let's go back here. Let's do a plot. I'm just making sure that I get notes for you. This is what I'm going to have to take a look at real quickly. So what we're doing first is defining the parameters to our plot. This is the format for the plot. We have to define what we're going to call our y-axis and our x-axis. So we start off with 4:6 ratio. And we want to do our x-axis is lakes. And you guys are okay? I like colors, so let's do lake. Okay, now we have to do this part. Data equals subset. Oh, there it is. Nope, screw it up again. Where'd our script go? What's that? What's that?
Could it be the comma next to the 4 to 6 ratio?
Could be. Nope, there it is. I was missing a parentheses.
Hmm.
Yep. Okay. So all we've done at this point in time is just created the parameters for a figure. We haven't put anything in there, haven't made it look good. We just have the parameters. All we can do is do the figure. So let's do. Okay, ignoring the text above, this is one format for a figure.
Okay.
These are box plots. Each one of these individual points represents a fish. As you can see, you have a lot of variation among fish. All of the ratios tend to be above 1, with a few exceptions that are right around 1. You have the GCL for lake, the GCE for effluent. We could rename those. We have the fin ratio, 4 to 6 over the side, and we have the status of lake, whether it's effluent or natural water. Does this make sense? Can you tell me why these are not significantly different? Are these boxes basically the same height?
Yeah.
You got a ton of fish. They're all showing masculinization. You know, they're all above the ratio of 1, but they're pretty equivalent between those two groups. So one of the things that's kind of nice for posters, for presentations, you can just put down the 4 to 6. It's anal fin ratio, right?
Yes.
Gambusia was small natural lakes versus lakes with effluent.
Marlene, do we want to call it effluent or do we want to say reuse water lakes? Even though that's what effluent means, but
I'm not sure. What do you think is better?
from a perspective, Dr. Gunnels, of who doesn't know really what we're doing, would you think it's more beneficial if when we're presenting we were to say effluent lakes, or would it be better to say reuse water lakes?
I think it's okay to say effluent, and then when you talk to someone, you can define that.
Okay.
Because I think it's a really good observation in the sense of when you talk to someone, you could say, this is water that's been reused, treated, and therefore has a lot of high nutrients.
Okay.
That's a great question. Okay, so one of the things I love about R is you can start, and then you can just start adding in stuff. Oh, what did I do? What did I do? Oh. Try this. Oh, no. What do I do now? Right. Ugly. Ugly. Where am I making a mistake? Oh, so now the parentheses. No, that parentheses stays. No. No, that parentheses is not. There we go. So you can add on little pieces. You can make little adjustments. Like, do we want to change these? Yeah, don't you think? Yeah. Let's see if we can do that. I think we can do that. Still feel manual. Nope, we don't care about that. Let's see if I know this.
Just out of curiosity, what does permutated ANOVA mean?
Yeah, great question. Do you remember what an ANOVA is from stats class? So an ANOVA is where you compare two or more groups, and you have two groups. You have a lake with reused water and a lake with natural water.
Mhm.
And this has assumptions of things like normality. It makes a nice little bell curve, stuff like that. What a permutation test does is it uses the same basic idea, but instead of worrying about the data being normally distributed, and your data is not normally distributed, yeah, you can see you have some very wide, far away, large data points. Everything around here, these are all big, huge outliers. And that's fine. So what permutation does is it takes the data that you measured, it runs that test, and then it runs 10,000 random resampling of these data points, but each time it randomly associates it with one of the two groups. So it takes every single data point and it randomly redistributes them and then reruns the test. And what it does is it compares your first measurement, what you really observed the first time, with the thousands of randomized reassortments of the data. And those are called permutated data. It's awesome. It's wicked cool. It allows you to avoid things like normality, and it allows you to analyze your data relative to the distribution of data that you measure. Now, all that might just seem mathy, and therefore you don't really have to worry about it. You can just go with it's cool, and it allows you to look at true biological data by permutating the analysis. And we can talk about those in more detail at a later point if that is of interest to you. So now we're going to find with this. Well, looks different. All right, well, instead of deep diving, we can fix this later. What I'm going to show you is another representation. And ultimately, you guys are going to be the ones who decide. Oh, that's not going to work. Why? This is another way of looking at the data. These are traditional bar graphs. The benefits is they can be more clear because they're simple. The con is that they're not terribly realistic. And two, like in this case, you don't really see anything.
Right.
So that is a choice. Let's not bad. Let's do all I'm doing is just separating out this scale and separating out these a bit. But these can be a way of representing your data. So I apologize. I have to get to my next meeting. What I could do is a few things now. Ooh, that's good. Top off, and this is for lake. Natural. Then you can just save figures as PDFs. They sit perfectly in posters and you're ready to go.
Okay.
This is box.
Marlene just texted the reason why her thing shut off was because her phone just died.
No, not a problem. Not a problem. Because I have to literally leave for another meeting in 2 minutes.
All right, no
Does
problem.
this give you a start?
Yes.
Next time that we meet, all this stuff will be there. I'll send you and Dr. Demers and Marlene the plots that we made so far. So
Okay.
you can kind of take a look at those and see if they're making sense for what you want to explore.
Okay.
And then we can proceed from there.
All
okay.
right.
All right.
Should we choose a time that you sent in the email? Is it okay if we choose a time from that, or unless like those availabilities are gone now?
They change every week. So we
Okay.
could start from that. So start from that. Let's see if we can find something and maybe give me like a first choice, second choice, third choice, and we can make it work from there.
All right, perfect. Thank
Okay.
you so much for your help.
Absolutely.
Have a great day.
You too. Hey, Marlene, we just finished up. I heard your phone died. Sorry about that, buddy.
Yeah. Sorry.
Not a problem. It's good to see you. Jinka is gonna, Junkie?
Yeah.
How do I say her name?
Junkie.
Junkie. Okay, Junkie is going to reach out and we'll set up another time. Okay?
Perfect. Thank you.